Hello, and welcome to the Museum of Science's Ethics and Biotechnology webinar program. I'm your host, Insoo Hyun. I am the director of the Center for Life Sciences here at the Museum of Science. This is a webinar series that's co-sponsored by the Harvard Medical School Center for Bioethics, and its purpose is to bring you, the audience, together with experts in the field of biotechnology and bioethics to talk about emerging and very important issues that affect us all coming out of this technology. You are able to participate in today's conversation by typing in your questions to our speaker in the Q&A function at the bottom of your screen. Don't use the chat function, use the Q&A function, and my co-instructor, Lauren Walsh, will be moderating the conversation with you, the audience, later in the program. So the topic today is polygenic embryo screening, the promise and perils of selecting our children's traits. This is a very timely conversation. I'm so lucky, we're so lucky and fortunate to have Dr. Vardit Ravitsky join us today. She is an expert in this area. Vardit is the president and CEO of the Hastings Center, which is a renowned bioethics institute in New York. She's also professor of bioethics at the University of Montreal, and she is a senior lecturer on global health and social medicine at Harvard Medical School. Dr. Ravitsky is an expert on the ethical, social, and policy implications of genomics and reproductive technologies. Vardit, it's so wonderful to have you. Welcome to the program.
Thank you so much, Insoo. It's a pleasure to be with you today.
Now, this topic of polygenic embryo screening, a lot of people may get this confused with what's called pre-implantation genetic testing. Now, that has been around for a while, but could you start us off just by explaining the difference between those two technologies and explain a little bit more what exactly polygenic embryo screening is?
So I'd start out by saying that, everybody wants to have a healthy baby, right? Nobody wants a child to see their child born with a serious disease. Nobody wants pain and suffering or premature death. So all these technologies are meant to help prospective parents make informed decisions about their embryo selection. If they go through IVF and they have several embryos to choose from, how to make that choice in an informed way. What polygenic screening brings to the table is the idea of screening out not just diseases that will definitely occur, not just diseases that are based on one single gene, a specific variant of that gene, but rather common diseases, things that affect most of the population, heart disease, diabetes, diseases that occur later in life that not all of us will get, but some of us are at higher risk for, and disease that are associated with multiple genes, not just one. So imagine that you're going through IVF yourself and that you have 3 embryos to pick from. And this kind of testing can tell you that this one on the left will have reduced risk of heart disease. This one in the middle would have increased risk of schizophrenia, and the one on the right will have a reduced chance of obesity, for example. Mm-hmm. And that is supposed to help you make the choice between the 3. And of course, I selected these examples to start showing us that these choices are not easy at all.
That's fascinating. So in the case of the pre-implantation genetic testing, typically that's triggered maybe by a family history of genetic disease, or there's kind of some reason why, in addition to having IVF, or actually it might even be you're doing IVF, not because you need the technology to reproduce, but you actually want to have the screening. So there's usually some kind of like medical history or something that triggers that. But it sounds like for the polygenic embryo screening, there's not necessarily any kind of like medical history. You just want to have more information that's predictive about your embryos. Is that right?
That's exactly right. So PGT, pre-implantation genetic testing, usually is triggered because of an indication, a medical indication. So for example, those parents already had a child with Tay-Sachs, which is a terrible disease that affects very young children and involves a lot of pain and suffering, and they want to avoid having a second child with that disease. And so they go through IVF in order to target that specific gene. So they test a single gene for a known disease for a reason. And all of those things are different when we talk about polygenic screening. So because these are common diseases, people would be interested in it even if they don't have a specific medical concern in the family. And multiple genes will be tested, not just one. And then that raises the question that you hinted at. If you're going through IVF for infertility, because you need IVF to conceive anyways, you're facing the choice to add on this testing. You can just go through IVF and randomly select which embryo to implant, or you can pay extra money to do PGT to look at specific genes because you have specific concerns. But if you don't have infertility issues and you could conceive naturally, what would justify going through this really burdensome, costly, and medically risky process of IVF? So let's paint a scenario where some women in my family died of breast cancer, and I'm very concerned about this disease. And it's worth it to me and to my family to go through IVF, pay all this money, get all these injections and hormones, invasive procedures. All this is worth it for me to prevent the implantation of an embryo with higher risk of breast cancer. You can see where I'm coming from. But does it make sense for me to go through all of that, to do IVF, just in order to select an embryo that maybe has reduced chance of heart disease or diabetes? That frames the question quite differently. So people who are already going through IVF for infertility maybe will want to add on polygenic screening to the traditional, now seen as traditional genetic testing, PGT. But will people want to go through that just for polygenic screening? Interestingly, a survey was just conducted in the US, and I'll let you guess what percentage of those surveyed, there were almost 1,500, representative for race, gender, and age. What percentage of those surveyed said that they would go themselves through IVF just for this purpose?
If they had, assuming the resources to do that?
Of course.
Yeah. So, Professor, I'm going to try my best to make a guess at your question. I would say the majority.
Really?
Yeah. That's
wow.
If they had the if someone said we'll pay for it, you could do it if you want. I would guess over 50%. Was that way too high?
Yeah. So again, I'm reminding you that
Professor, I failed. I'm sorry.
That entails going through the lengthy and uncomfortable, borderline painful, and process of IVF that entails medical risks. So the number was 30% who said they would go through IVF just for that. And I found that number surprisingly high. But that could be because people don't fully understand the limitations of this technology. And I'll just throw the other numbers out there because we're talking about what people are interested in. You were right overall. 72% said that this type of screening of embryos should be allowed, and they overall approved of it. And I found that very high. 82% said they would use it, but that was if they were doing IVF already for other reasons. And 67% thought that the benefits outweigh the risks. Now, this is not a huge survey. It's a few hundreds, but I was really surprised by these the results. The high percentage of people who support this, who are interested in this, I was really surprised. And I think this speaks to the fact that people don't fully understand how premature the implementation of the technology is.
Yeah. Well, I'm wondering, though, in my case, when I gave my answer, how much of my Asian male brain was working there? Because clearly I wouldn't have to be the one undergoing this procedure. I guess I'd be volunteering my wife to do this when I say I would be in favor or I would do it because I physically can't do it. And I wonder if there are some like cultural factors involved about how important it is for one to have children who are successful, children who, are thriving in kind of the standard ways that we define that.
That is so interesting. One of the things I was going to bring up later in our conversation, Insu, is indeed the cultural frameworks that are sort of the context of this conversation. Because if you're taking this technology as a way to not only prevent serious disease and not only prevent common diseases that are maybe less serious, but even to select traits, then by using this technology, by approving of it, are we sending a general societal message of competitiveness and excellence and perfection, and this notion that parents should do anything that they can to promote the chances of their children to succeed? And what does success look like, right? We all have our biases and our preconceived notions of what success is and how to equip our children for success. So these are all becoming very quickly not clinical questions, but rather value questions and societal and ethical questions.
That's so interesting. So earlier we had said that pre-implantation genetic testing is usually triggered by some sort of medical history or some issue of concern. But can you tell us about the people may have heard of the possibility of doing this kind of screening for sex selection of the embryos. Now, is that something that's kind of, been, people may have heard of it, but is that something that's actually been practiced? Is it banned in places? So clearly this is not for a medical reason, but it'd be kind of like for like family balancing, or kind of like you want to have a boy, or this time you've had too many boys, you want a girl finally. So you're trying to select embryos based on sex. Now you can do that with current technology. You don't have to go to the polygenic embryo screening. You can just do sex selection from pre-implantation genetic testing. So could you speak to that a little bit, that technology for sex selection?
Of course. So pre-implantation genetic testing has already been allowing this for a while. And you work right to, first of all, distinguish the medical uses from the non-medical, because some diseases are sex-linked. And when somebody wants to prevent the implantation of a male or a female embryo, it's for a medical reason, and that's considered very legitimate and ethically acceptable. The issue is indeed family balancing, or more problematic, cultural preferences for boys. And some countries have used various technologies, testing of embryos, but also termination of pregnancies after prenatal testing to select for boys in that way. And that has already resulted in several societies that have a skewed sex ratio. Basically, naturally, about 100 boys are born per 100 girls, a little over the exact ratio. But in these societies, there's 120 boys or even 130 per 100 girls. And that creates social unrest and increased violence against women and a lot of societal problems. So in those countries, sex selection based on genetic testing has been banned by law, and people circumvent the legal prohibition and find ways to do it anyways. What's interesting here with polygenic risk screening is that this service is offered commercially. You just buy the service from a company. And this can be done, and the results can be available to you online, of course. So you could cross national, boundaries. And, you could always travel to another country to do it. But you could also access the information from where you are through an American-based company where everything's allowed here. So these are all fascinating questions related to social preferences, cultural preferences, and social practices. And also this notion of reproductive tourism, where people from one country travel to another country to have access to services that they don't have where they live.
For the genetic testing, that's to determine whether or not the gene is present or not. But for polygenic embryo screening, that is, I as I understand it, it's more about the risk factors or the probabilities. Could you speak a little bit more of what exactly the polygenic embryo screening is going to sort of produce as an answer when you do that test? It's going to be like a percentage. What comes out of that analysis?
That's a great question. And before I answer it, Insoo, will you allow me to show the first 2.5 minutes of the film Gattaca? Because there's a science fiction film that maybe many of you have seen. It's almost 30 years old now and still totally fresh when it comes to its depiction of a future society where almost everybody is born following polygenic screening of themselves when they were embryos. And you just highlighted the notion that these are just risks, not certainties. And that is correct. If you're a prospective parent, what you would get is just a list of numbers that are all percentages representing the risk that your potential future child will have A, B, and C. But I want you to see how this plays out in the film, and then we will deconstruct it, understand the technology, and understand the ethical implications. Great. So give me 2.5 minutes of this.
If this were a classroom, I'd tell somebody to turn off the lights. We're going to roll the film.
I was conceived in the Riviera, not the French Riviera, the Detroit variety. They used to say that a child conceived in love has a greater chance of happiness. They don't say that anymore. Never understand what possessed my mother to put her faith in God's hands rather than those of her local geneticist. 10 fingers, 10 toes, that's all that used to matter. Not now. Now, only seconds old, the exact time and cause of my death was already known.
You can ask her to turn it up. You can ask her to turn the volume up. Marty, can you turn up the volume?
Manic depression, 42% probability. Attention deficit disorder, 89% probability. Heart disorder, 99% probability. Early fatal potential. Life expectancy, 30.2 years. Name of the certificate?
No, Vincent Anton. Like most other parents of their day, they were determined that their next child would be brought into the world in what has become the natural way. Your extracted eggs, Marie, have been fertilized with Antonio's sperm. After screening, we are left, as you see, with 2 healthy boys and 2 very healthy girls. Naturally, no critical predispositions to any major inheritable diseases. All that remains is to select the most compatible candidate. First, we may as well decide on gender. Have you given it to me, Mom?
We would want Vincent to have a brother, to play with.
Of course you would. Hello, Vincent. You have specified hazel eyes, dark hair, and fair skin. I've taken the liberty of eradicating any potentially prejudicial conditions, premature baldness, myopia, alcoholism, and addictive susceptibility, propensity for violence, obesity, etc.
We didn't want, diseases, yes, but...
Right. We were just wondering if it's good to just leave a few things to chance. Want to give your child the best possible start. Believe me, we have enough imperfection built in already. Your child isn't needing additional burdens. And keep in mind, this child is still you. Simply the best of you. You could conceive naturally 1,000 times and never get such a result.
Was that audible?
Yeah, that was great. They did call out baldness, so I would not have made it as an embryo. I would have been screened out. So I'm glad that actually doesn't exist, not in Korea back in the 70s.
So you now understand why I was eager to show this clip. We're talking about this technology as something that is emerging, still experimental, I called it premature to offer. But 30 years ago, they imagined a society where most children are born on this basis, and doing it differently is seen as irresponsible and as penalizing your child because you're not giving them the best chances in life. So what I found fascinating always in this clip is that he tells them, he narrowed it down to 2 of each sex, and he tells them that he already eliminated all of these things. But the reality is that if you have a limited number of embryos, one will have a higher risk of X and a lower risk of Y, and the other could have it the other way around. So let me present you with some scenarios. Let's say you have 2 embryos, just like in the clip, okay? One has a higher risk of heart disease, but a lower risk for diabetes, but the other is the opposite. How do you choose between them? What if one has a high risk of heart disease, but a lower risk of schizophrenia, and the other has it flipped? So how do you compare a physical condition to a mental condition? What if one has a higher risk of heart disease, but a higher chance of being tall, of what we call high educational attainment, a higher chance of graduating from university or being a competitive athlete? So now imagine you have 10 embryos, and each one has a different configuration of risks and chances. Some of them are physical, some of them are mental, some are cognitive, some are about physical traits. How are prospective parents supposed to weigh and compare these factors in order to make the best choice? What does that mean? So one company that offers this testing and is detecting 1,200 different conditions that way offers one number that captures sort of a combination of all of these factors, and they rate your embryos for you. They give like a final grade to each embryo to make that thought process simpler for prospective parents by telling them, grading them from like best to worst. But that means that they use their algorithm to compare and contrast all these apples and oranges.
Yeah.
So I'm just putting it out there. The decision-making is not what it is in Gattaca. It's going to be excruciatingly complicated.
Yeah, I mean, the philosophically trained bioethicist in me thinks that's ludicrous because you can't compare all these apples and oranges and pump out one score. I mean, they're not on the same scale of measurement or unit of measurement. Well, that's remarkable. Now, I'm a little bit confused because it seems like you're comparing, you're trying to select amongst the embryos that came from 2 specific genetic parents. There can't be that much range or that much difference in your pool there, right? Like you've got 4 embryos from these 2 genetic parents. I can't imagine there'll be that much of a difference in range of these risk scores. Or am I wrong? Like, can they actually be quite different?
No, you're right. You're mostly right. So we have to remember that because this is associated with multiple places, multiple locations in our genome, first of all, it's not predictive in the usual sense. If you have the variant that causes Tay-Sachs, you will have Tay-Sachs. But here it's all about increased risks. And the risk, of course, is determined by both your parents. So the embryos won't be maybe that different. They will be differences, and these differences can inform a decision, but they won't be potentially wildly different. And the other thing is that the level of risk means that there's still a good chance that the disease will not occur, or if you're trying to select for a trait, there's also a chance the trait won't be there. So this science fiction notion that if you select embryo number 5, you're going to get a perfectly healthy, tall astronaut who plays the cello and has a charming personality. That's not what this is about. This is really incremental, small increases in the risk. And the way the risk will play out in life is very different. Maybe you will be sick, but only mildly expression of that disease, or maybe it's severe, and we can't tell you that ahead of time. So there are many limitations to this technology.
Yeah, when I think about my own children, I think about other people who have families. It's interesting. I mean, you do see a range within children of a particular generation in one family from parents that they may, like one may be pretty shy, one may be more outgoing. There are differences, of course, but I just don't know how much of that could be attributed to the genetics. Clearly, there's a complex genetics and environmental kind of interaction.
Of course. And that's another limitation that I was hoping that we would get to discuss. Because when we tell parents, this embryo has the highest score, and that means that it will have a reduced risk for all those bad things and a better chance of those good things, we're sort of sending the message that future identity, future happiness, what we talked about, success in life, is determined by genetics. And that is very worrisome, considering so much of who we are depends on the environment. Ethically also, because if we put so much on genetics, it absolves us of the responsibility to improve our environment. So what about parenthood, and what about resources and social justice and social determinants of health? If we put so much on genetics, we take those responsibilities off of ourselves and off of society and off of policymakers. So to me, that's very worrisome. I want to show you real quick the website of one of the companies that sell this test. And I don't want to target this one compared to others, just as an example. So this is Genomic Prediction, one of the first ones to offer this as a package. Better tests, better outcomes. But I want you to see the bottom of the screen, choice over chance. And that is really the message here, that if you're a responsible parent and you have the ability, you should avoid chance and favor choice and informed choice. Anyways, I don't want to spend too much time on this website, so it won't look like any type of promotion.
Sure.
But feel free to go online and check out these companies because it's so fascinating.
Yeah.
We have to remember, Insu, that the technology is based on what we call genome-wide association studies. To put it simply, you take 100,000 people and split them into those with schizophrenia and those without. And then you sequence their genome. And for the group that has the condition, you're trying to find what's different in multiple locations across their genome compared to the other group. So this is purely statistics. There's no causality here. Nobody can tell you how these variants are causing the condition or what the phenotypic expression will be for the future child. It's pure statistics. And the message of choice over chance, to me, is a misrepresentation of how little we know about this, because it gives prospective parents the impression that they have control over the identity of the future child. And that is really not the case here.
Yeah. So let me play devil's advocate a little bit. So what if somebody says, Vardit, we do versions of this all the time. We may not always be successful, but we try. So some people may seek very tall partners because they want tall children. Or they're kind of scrolling through the alumni list of their university because they want people who have like the same kind of educational aspirations and talent. We sort of try to do that. We're not very good at it. I can't guarantee anything, but we think that it might increase the likelihood that you get this kind of outcome in your children. What's wrong with doing it kind of this, taking this next step and doing the embryo screening? Isn't that kind of all along that conceptual path of sort of, doing what you can to control the traits of your children?
Great question. And some bioethicists indeed support this technology because they see it as yet another tool that we employ to enhance the well-being of our future children and maybe even the well-being of society. Why am I worried about this? If I choose you, Insu, as a partner for procreation, the number of traits and the medical information that I have, it's quite a simplistic choice. Here at the individual level, if you actually get the genetic information for 1,200 conditions and traits, I'm concerned that, first of all, we're sending this societal message about genetic determinism, that this is the right way to choose which child to have. And second of all, more pragmatically, the informational overload that this would put in front of parents and the sort of decisional paralysis that this would create. Because again, these are apples and oranges. This is all statistics, no clarity over how this will play out in the life of your child. We're beginning to, this is barely implemented. It's really an emerging technology, but we're beginning to see examples where people got information about, let's say, 5 embryos and decided not to implant any of them because each one had something. And how do you assess what kind of risk is acceptable to you and what kind of trait sort of outweighs a positive trait outweighs the risk of a negative trait? It's just so complex that I think we're putting prospective parents in impossible situations.
So you mentioned that these risk scores are set against the background of genome-wide association studies. What are the populations used for those studies? Are those like typically representative of the people who are going to be using the screening?
So these studies are typically done on populations of European descent with huge overrepresentation. And so I have Polish genetic origins. If I were to use this, I would have better results, more predictive results than you coming from a different background. And this is a huge problem because it's an issue of equity and justice, that because for years we have been studying white populations from European descent, now the tools that we have perform better for these populations, and minority patients who come from other ancestry backgrounds would not have the same performance of these tests as I would have, for example.
I want to probe a little bit more, kind of like what your position is on this. Are you like categorically opposed to any of this type of screening, or is it like you think that we're not ready yet based on the information we have, that it's not really reliable, it's misleading? What's kind of at the heart of your concern about this technology?
So as I said, at the individual level, it's about how patients will cope with this. It's also about women feeling pressure to go through IVF in order to do this when I think that it's clinically not ready for prime time. Because again, IVF is not innocuous. There are many burdens associated and also long-term risks. I'm very concerned about this technology being portrayed as the responsible way to have children, and then women feeling pressure, families feeling pressure. Does it promote a eugenic message? Well, at the individual level, if you're feeling pressured to use it, then yes. And at the societal level, it means that we're sort of, again, sending the message that certain traits should be screened out and others are preferred. And that really resonates with a dark history of eugenics and this whole notion of engineering a human society based on genetics. So all of these are concerns that I have. I think the science is not there yet. The predictions are not strong enough. And the most critical concern that I have is about the famous distinction between using this for prevention versus enhancement. So if you suggested this to me, if I came from a family with very high risk of heart disease, and you suggested this to reduce the risk of my prospective child, and I was going through IVF anyways, maybe I'd see the value in this. But to choose for height, for IQ, for educational attainment, for complex traits that are highly dependent on the environment, and that can really enhance these sort of eugenic tendencies in our society, the combination of how non-predictive the test is with the societal risks of employing it, I would be totally against at least now, and I think long term, and I would definitely myself resist using it for such purposes.
Interesting. We're going to turn to audience questions very soon. And so if you have a question from the audience, please type it into the Q&A box and we'll get to that in a moment. Let me ask you, Marty, what do clinicians think about this technology?
That's interesting, Insu. So we don't know yet, but a small qualitative study interviewed clinicians who offer IVF and IVF patients and asked them about this. Mm-hmm. And the results were interesting because everybody was relatively enthusiastic about, as you predicted earlier on, everybody was enthusiastic about the technology, but the clinicians urged caution and prudence, while the patients were like really leaning into this and saying that they would use it, that they approve of this being available publicly. There was some alignment between clinician and patients in terms of the distinction I just mentioned. So patients said that they would support it more for health conditions than for the selection of polygenic traits. Mm-hmm. But overall, clinicians were much more reserved and much more cautious than the patients who said, oh, yeah, I would want it. I would use it. It should be offered. It should be available now already. So you see sort of that divide in attitudes. Again, a small qualitative study. Mm-hmm. The results are of limited, we can't really extrapolate. But to me, that wasn't surprising that clinicians who understand the technology better urge more caution than the patients who just want as much information about the baby as they can get.
Mm-hmm. I find it fascinating that there's this aspiration. It probably is not realizable now, but aspiration that polygenic embryo screening could be used for kind of like the better health or optimal health of your child versus screening for socially desirable traits or socially advantageous traits. And on the latter category, socially advantageous or desirable traits, like beauty, intelligence, athleticism, things like that are like not medically necessary conditions. The philosopher Frances Cam had a wonderful essay where she argued that our collective imaginations are so bad, so limited about what that actually is, that we could produce, if this were reality, produce a future generation of people who are just all kind of bland and boring and kind of look the same and kind of there's no like spark of individuality or like great genius creativity. So I thought that was a really interesting argument. It's basically the argument of this: we're so bad at kind of, letting our imaginations go about what's a good social trait that we tramp down those things that spontaneously arise and make life very rich. So that was a pretty cool argument. So with that, let's go ahead and see what some of the questions are that have come in. So Lauren, why don't you read off?
Thanks so much, Vardit, for this very interesting discussion. We have a lot of interest from the audience. The first question is about oversight. So polygenic embryo screening in the US is relatively unregulated. What do you think? Do you think there will be movement on that front to increase regulations? And do you think such oversight is necessary?
So indeed, in the US, any company can sell any test using this technology. So there is no regulation currently, and we see it play out in the commercial space. But when we look around the world, in the UK, this is illegal. In Germany, it's illegal. Canada doesn't allow sex selection, fetal sex determination with PGT already. So this would obviously be limited. I think that the chances of this being regulated in the US are slim. If we look at the history of how little we regulated any other reproductive technology, what I think we should do is protect consumers. And I'm not saying patients, because if you don't need IVF for fertility reasons or medical reasons, and you're doing it only for polygenic screening, you're really a consumer of a service. And you deserve protections like any other consumer. So if companies make unbased claims on their website, and if they exaggerate the benefit or misrepresent the benefit and the risk balance, then that is a regulatory issue that should be addressed and resolved. So do I see professional societies getting into this space? Absolutely, yes, because in the absence of regulation, a lot of it would be about what clinicians feel comfortable offering and how they are able or not to counsel their patients. So this is really a place where professional societies can come in with guidelines. They can't enforce them, but they can definitely put them out there, and that would help clinical practice. And I think that the least we can do is protect consumers from misleading information and make sure they get the best evidence-based and the best framed information when they make their choices.
Thank you. That makes a lot of sense. And continuing on your point about the patient as a consumer, which sort of happens in this environment where there's no regulatory oversight, do you think that it's too early? Like, should we not have moved this into the commercialization state? In which case, should we have instead done such polygenic embryo screening in the form of research so that we would have some human subjects research oversight and IRB review?
Absolutely, yes. I think one of the biggest lessons learned in reproductive technology in general is that we made the mistake over and over again of implementing new technologies straight into the clinic or the commercial space without going through a research phase. We did it with IVF more than 40 years ago. Louise Brown, born in 1978, the first IVF baby, was not a part of a clinical trial. Her parents needed help, and Dr. Edwards had them, and she was just born. And then it hit the ground and started running. And consequently, we didn't collect longitudinal data for decades about the health and of the children that we created in that way. There are multiple reasons for doing things via research first. PGT that we discussed in length. Testing of embryos for single gene disorders was implemented straight into the clinic without a clinical research phase. So it's so interesting that in this one particular domain, we just come up with a technology and we start using it, offering it, commercializing it without a clinical trial phase, which would have allowed us, as you said, the appropriate oversight. There are multiple reasons for why the history of the field looks like that, but I'm so eager to at least now learn this lesson and do this properly.
Thank you. And to your point about longitudinal data and the absence of it, some are concerned that using polygenic embryo screening for adult onset disease probability is more problematic than using it for childhood onset disease probability because of the fact that we just don't have the longitudinal data to know how effective the predictive risk factors are. And there might be medical research that happens between now and when the particular embryo becomes an adult that would help treat the given disease that the risk is being identified for. Do you think that polygenic embryo screening should be limited to only childhood onset diseases, or is it too premature to make that judgment?
I'm not sure that the distinction is helpful. So let me say something that can be interpreted as supportive of this technology, and then I will qualify it. Think about the way we use genetic testing for BRCA, for increased risk of breast and ovarian cancer. We test adults in order to allow them better screening and earlier preventive measures, and we see these tests as clinically effective and actionable, and therefore we want to offer them. So why not just backtrack and offer it at the embryonic stage? And instead of me needing a mammogram every year after the age of 40 because of my genetics, me never being born with that increased risk and somebody else being born with a better chance instead of me. So it's not that these tests are completely useless if they're used based on good evidence and for the correct types of conditions. But I think where it becomes problematic is when we think, okay, let's just use it when it's justified. And by justified, we mean to prevent serious disease. Because the term serious is very complex. And when people say, oh, it's ethically acceptable because this is serious, what they mean is multidimensional. They mean early onset, high mortality and morbidity. They mean pain and suffering. They mean limiting important life opportunities. They mean a lot of things. And only one of those things is early onset versus late onset. Huntington's disease is still very serious, but it gives you about 40 years of healthy life before it shows up. Does that make it less serious? I don't know. It's just a really complicated question. So to just draw the line between childhood onset and late onset, to me, is not a sufficient way to distinguish what makes this justified.
Thank you. Our audience is also interested in the idea of justice and equity in terms of access to this technology, and whether it might be cost prohibitive or not geographically available to all who might want to use it. So I have two questions for you on that front. The first is, how often do you think this is being done? How often is polygenic embryo screening being used just generally in the US as of right now, if you have a sense of that? And secondly, do you think that insurance should or would cover this at some point?
I don't have the empirical answer. Maybe companies put their numbers out in public. I haven't seen, and I just don't know. The first baby ever born from an embryo that went through polygenic screening was born in May 2020, so 4 years ago. How many babies were born since then, I really don't know. It's obviously not prevalent yet. The justice aspects are very extreme here because IVF in and of itself is very expensive. I would say prohibitively expensive for many, many people, hovering between $10,000 and $30,000 before any add-ons. And this test is a few more thousands. Now, people who already spend the money on IVF because they have to often feel that it makes sense to add another $2,000 for pre-implantation testing. And maybe they will feel that it makes sense to add a few extra $1,000 for polygenic risk score. That's sort of the economic logic of couples, but insurance is a big issue, of course. Some states in the US mandate insurance coverage of IVF, but not all to the same extent. You can cover the drugs or the procedure, and what about the freezing of the leftover embryos? And so there are many aspects to this, and not all states cover to the same degree. This will probably not be eligible for insurance coverage for a very, very long time because, again, the evidence base is very weak, and the clinical effectiveness is almost non-existent at this point because we just don't know how the children who are born of this fare compared to other children. So I don't think there will be any justifications for insurance coverage for a long time. And that creates a serious inequity issue because the people who will be able to afford this will be the people who can pay for it out of pocket.
Mm-hmm. That makes sense. We have some questions from our audience on how polygenic embryo screening might change the physician-patient relationship and the physician's role in procreation. So some think maybe the physician could be sidelined and be put in a position in which the physician is just sort of facilitating the patient's choices instead of weighing in a little more heavily on what should happen, especially if you're going through commercial companies to do this. And others are worried, and they would like your thoughts on whether doing polygenic embryo screening without a need to do it, just sort of doing it in the sense that you want to optimize your embryo and future offspring, might that be in violation of the Hippocratic Oath to do no harm?
So first of all, thank you for this excellent question. Using need in this context, to me, is problematic across the board. Nobody needs this. Even if you have a higher risk of a condition in your family, there are other technologies that you can use. There are environmental interventions. There's, again, social determinants of health that can assist in the future. So calling this a need, a medical need, is to me problematic to start with. Interestingly, the small qualitative study that I referred to, where a bit under 30 clinicians were asked about this, they expressed the view that it's not a part of their job, that it's not something that is supposed to be provided by clinicians, especially for traits. So this notion that, you became a clinician to help people and to prevent disease and to treat disease. And all of a sudden you're helping people choose a tall prospective child. That just felt off to many clinicians. And they said, I don't want to offer this because it's not the reason I became a doctor. It's not, it shouldn't be a part of my role. Whether clinicians will be sidelined by this, I don't know if people go straight to a company. I mean, someone has to provide IVF. Someone has to do the clinical intervention here. So I don't think clinicians will be out of the picture. But what I fear is if this becomes more and more standard, that parents will feel that if their child then is born with increased risk of something, that it's on them that they didn't select a different embryo early on. It's the kind of societal pressure that plays out sometimes through the medical establishment when your child presents with a disease and you're told, oh, why didn't you do prenatal testing? And in this case, why didn't you do pre-implantation testing of your embryos? And someday maybe, why didn't you do polygenic screening and choose a better embryo? And now look at your child suffering and costing us all this money. I'm very worried about that trend towards pressure to use technologies getting to the stage of polygenic screening.
Vardit, I had a question. So I assume then that for polygenic embryo screening, what you're doing in the clinic is taking off a single cell at a very early stage of embryo development, and then screening that single cell, doing genetic analysis on that single cell. There has been some concern or some worry that even with pre-implantation genetic testing, when you take off a single cell and you analyze it, that removal of the cell may affect slightly the success rate for implantation in pregnancy, or may have some downstream effect on the embryo. Have you heard of that kind of concern? Because if that's true scientifically, then doing the screening for no real health reason but to try to select desirable traits may be exposing the embryo to an unnecessary, maybe minor, but unnecessary risk.
I'm not the scientist doing these studies, and I'm not a clinician, so I'll be very cautious. But PGT has been around since the very early 90s, so for decades. And I haven't seen any aggregate evidence that it's harming embryonic development at that early stage. Mm-hmm. I haven't seen it. Maybe there's new data that I'm unaware of. Mm-hmm. But I take this opportunity to emphasize that there are other reasons to not use it for trivial reasons other than harming the embryo, and that is harming the woman. Mm-hmm. Because again, to have the embryo in vitro mm-hmm. and not in vivo, in order to test it, someone has to go through IVF, get hormone injections, mm-hmm. get anesthesia, get invasive procedures. That someone is the woman. And if there is no indication, then we can't, I don't think we should be too banal about IVF in the context of, what is needed to get to the point of polygenic screening. So it's important to keep that on the table as a consideration. It's not just weighing the benefits and risks of the screening itself. It's how we get to the point of screening. Mm-hmm, mm-hmm.
We have questions from the audience about the risk of devaluing certain traits as a result of polygenic embryo screening. So you mentioned the horrible history of eugenics that exists in the US and elsewhere. And others are concerned about disability justice and the work that many have done to destigmatize certain traits. So I'm wondering if you could speak to if you think polygenic embryo screening poses a risk in that area, and if so, how can we mitigate that risk?
The bottom line is I definitely think it poses that risk, because if it's offered in the commercial context as a product, then consumers will choose, and then we're facing the aggregate impact of these choices. So if every couple or every producer of embryos chooses polygenic screening to screen out schizophrenia or another mental condition, or screens in favor of height or a certain skin color, or who knows what, certain types of talents. That the aggregate impact of these choices is definitely to further stigmatize certain traits, to further send a societal message about how undesirable certain disabilities are, even though families raising those children and individuals living with these conditions thrive and flourish, and the only limitations they experience are created by the social constructs, not by their own phenotype. So this is definitely a technology that raises the risk of exacerbating eugenic attitudes and a further threat to disability rights and the acceptance of a more diverse population in terms of genotype. How should that go to the point of limiting individuals' choices? I don't know. That's always the question. This interplay between the societal concerns and individual autonomy is always the heart of the question. Not sure what the answer is. Considering how I see this technology is prematurely implemented, not effective yet, and playing into all these societal risks, I would say at this point, we have more reasons to not use it than to use it.
Thank you very much. And the last question I'll pose to you from the audience is about the similarities between some of the ethical concerns around polygenic embryo screening and CRISPR. So a couple of years back, there was a public discourse. You would often hear the term so-called designer babies and some public outrage against that. So I'm wondering if the audience would like to know, is there any similarities that we can learn from the CRISPR debates and apply to the polygenic embryo screening debates? And if so, what?
So the similarities are exactly around the debate that occurred between treatment or prevention and enhancement. So if we use CRISPR, what are the ethically justified uses? And there was global consensus that it would only be justified within a clinical trial if it's meant to prevent a serious genetic condition, which throws us back to the complexity of defining what serious means. The issue with polygenic screening is that it inherently targets not just serious conditions. It's common disease. It's a variety of disease. If you have 1,200 detected conditions offered by one company, not all of them will be serious to the same degree. So I think CRISPR was supposed to be implemented at least for a few generations, only to target single gene serious diseases, whereas this is inherently different. The other thing is, as we saw in the clip from Gattaca, when the clinician says to them, "Don't worry, this is still you, only the best of you." Polygenic screening still uses the sort of natural combination of egg and sperm and the newly formed DNA, whereas CRISPR goes into that DNA and edits it, cuts and pastes pieces to create something new. And that is a qualitative difference between the two technologies. One selects an embryo from others, all of them naturally conceived, whereas the other goes into the embryo and fixes it or edits it. And that is not just philosophically and ethically, but also scientifically a very, very big difference.
Well, Vardi, we're close to the end of our time. I want to give you the opportunity. What do you think is one of the most important science communication messages you'd like to make about polygenic embryo screening to the public?
I think it's really important not to let commercial forces drive those biotechnologies. There's a lot of money to be made. There's a lot of interests, consumer interest in this. People feel like to be responsible parents, they should know as much as they can about their newborn babies, fetuses, and embryos. But the reality, the scientific reality, the social reality is very complex. So when we let commercial forces drive this market and frame the messaging to prospective parents, we can find ourselves on ethical and social dangerous grounds. And I would like to end with a quote from a very recent paper in the European Journal of Human Genetics, that this is a group of bioethicists and scientists who say the utility of this practice of polygenic screening is severely limited To date, no clinical research has been performed to assess the effectiveness. Patients need to be properly informed about the limitations. And the last point, a societal debate focused on what would be considered acceptable with regard to the selection of individual traits should take place before any further implementation of the technique in the population. So I think today's conversation that we just had is a part of that societal debate. And one of my strongest messages is that we should have this debate before we implement the technology and not after.
Well, thank you for those final words. I want to thank Vardit Ravitsky, the president and CEO of the Hastings Center, for sharing her time with us today. I'd love to thank Lauren Walsh, my co-instructor, for moderating the questions, the staff of the Museum of Science for all your assistance, and the Center for Bioethics at Harvard Medical School for sponsoring this event. Thank you, the audience, for joining us today. Goodbye.